We are now on page 199. Number 1. Heidi says that the function is linear because it is in slope-intercept form. Neil made the table of values below for the function and concluded that the function is not linear because the first consecutive differences are not common. Which student is correct? Describe the other student's error. So the first thing I want to do is check my x column to see if we even have a function. And we do, because the x's are all unique. So we have a function. But we also have a problem. The x values are not consecutive. So I can already tell you that Neil has made a mistake. He is trying to use x values that are not in order. We skipped 0, we skipped positive 2, so we can say that the x values are not in order. They're not consecutive. So if they're not consecutive, the differences are not consecutive either. So Heidi was correct on this one. Okay, number 2. You have seen that linear functions have common first consecutive differences and that quadratic functions have common second consecutive differences. You have also seen that a third degree function has a common third consecutive differences. Make a conjecture or a prediction about f of x equals x to the fourth and common consecutive differences, then test your conjecture by making a table of values for f of x equals x to the fourth. So I'm going to need some paper. And let's take a look here at a table. Let's go ahead and draw. You're going to need quite a bit of space. And let's do 8 rows. That's a pretty good number to do these. And the first thing we're going to need to do is to set up the x and y values. So let's do that very carefully. So here's x and here's f of x. And I'm going to use -3, -2, -1, 0, 1, 2, 3. And I've picked up an extra row, so let me get rid of that. We don't need that many. You could do that many, but it isn't necessary. Okay, so here comes the first consecutive difference, the second consecutive difference, the third consecutive difference, and then the fourth consecutive difference. And that was a stroke of luck right there. It came out exactly right. So the function, remember, is f of x equals x to the fourth power. All right, so let's substitute f of -3. So that's -3 to the fourth power. And let's use the calculator to do these. So let me give you the buttons for the calculator. It'll take me just a second, but it's worth the time to draw it. First thing you want to do always is press all clear. And then you're going to put in your base. and then your exponent key, and then the exponent, and then your equal sign. So I will do these with you to let you get the hang of it. All right, so all clear. And then we put in what's called the base. And in this case, it's -3. Then the exponent key is x to the y. And then the actual exponent will be a 4 for all of these. So the only thing that's going to change is the base. That's the x value. So let me type it in to be sure I haven't done something weird. So 3 negative to the 4th power is 81. I'm glad we don't have to graph this thing. Okay, then we're going to change out the base each time. That's your x value. So f of -2, you just put a -2 in there and do the math. 2 negative to the 4th power equals +16. Then f of -1, you put in a -1 and raise it to the 4th power. That's going to be a +1. Now this one's tricky. 0 to the 4th power, be careful, is 0. 1 to the 4th power is 1. 2 to the 4th power is 16. And 3 to the 4th power is 81. So get your values. We know it's a function because the x's are all different. It's a 4th degree function. The y's are not all different, so it's not 1 to 1. That doesn't matter, but it's good practice. So let's look at the first consecutive differences. So I have 16 minus 81. 16 minus 81 is -65. 1 minus 16 is -15. 0 minus 1 is -1. 1 minus 0 is +1. 16 minus 1 is 15. And 81 minus 16 is 65. So the first consecutive differences are not common. That means this is not a linear equation. But we knew that. If it's 4th degree, it's not linear. Linears are 1st degree. Okay, so this would be called a linear. The x would have just a plain x. All right, the 2nd degree equations are called quadratics, or they can be, depends on the actual numbers. But okay, so we have -15 minus -65 is 50. And then 1 minus -15 is 16. 1 minus -1 is 2. 15 minus 1 is 14. And 65 minus 15 is 50. Now let me check that. Have I done something wrong? Negative? Yes, I have. And you know what it is. What do I always do? Yep, I forgot my negative sign. This is 1 minus negative 1. That's going to be 2. No. Oh, it's right here. Negative 1 plus 15 is 14. Sorry. Then I would have 15 minus 1 is 14. And then 65 minus 15 is 50. So the second consecutive differences are not common. That means this is not a quadratic equation. But we knew that. If it were quadratic, it would be second degree. Okay, the next one is called a cubic function when it's to the third degree. So let's see what our differences are. We have 14 minus 50, and that's negative 36. Then 2 minus 14 is negative 12. And then 14 minus 2 is positive 12. And 50 minus 14 is 36. So even at the third level, there is no commonality. So it's not a cubic function. All right. Last one is a fourth degree function. And let's look at 4 consecutive differences. So we have negative 12 minus negative 36. That's going to be 24. Then we have 12 minus negative 12, 24. And 36 minus 12 is 24. So finally, after all that, way out there, we end up with, I'm out of colors. I think I'll use this dark blue. We have consecutive common differences. But it all depended on what our x values were. Goodness, what a problem. And this was number 2.